My final project topic is activity classification using HMI. So this is the workflow of my method. At the beginning, I'm getting the frame sequences from video, and then I'm doing binary thresholding to get binary images sequence. And then I'm using HMI thresholding to get my HMI. And after that, I have constructed the invariant moments, and then I'll use some machine learning training method to train a classifier to help me do the action detections. So binary image is basically the difference between two adjacent frames, and we're using some thresholding to get it out, which is shown as the equations here. This method helps us to eliminate the static background and get only the motion out. So once I get my binary images sequences out, I can use that to construct the motion history images, HMI. The idea of HMI is that you can see it here that the area where you have higher pixel intensity is the area that the motion is just performed most recently. But at the same time, it's also recording the whole history of the entire motion. So that can be used as a description of the full extent of your motion. However, HMI is an appearance-based method. So in order to train my classifier, I still need some invariant descriptors. So in this project, I use scale invariant moment to use that as my descriptors for my motions. So it is a vector of size 8 and is a descriptor for the image pixel intensities. It's constructed from HMI. So I want to mention that who moment are also computed and tested for experiments. So I compared the performances. Actually, the scale invariant moment are performing better in testing accuracy. So that's why I use a scale invariant moment for my classifier trainings. The classifier I'm using for this project is AdaBoost, and the base learner for the AdaBoost is decision trees. I want to mention that I'm using 6 tau value to better separate the actions from each other. So combined with the invariant moment size of size 8, that one of the training data set is a vector of size 48. So after choosing the classifier, I do the machine learning training process. And this is the statistical analysis of the result. As you can see here, the training and testing accuracies are pretty high, and this is showing the confusion matrix of my testing set. Most of them are classified correctly, but it's just you can see that jogging, running, and walking, they're sometimes confusing each other. At the end, I'm also using a video to do a validation. So as you can see that most of my actions detected correctly. For improving this project, I think I can use some local movement from hands, arms, legs. I think with the local movement as descriptor, I can better separate the motions out, especially for walking, jogging, and running. That's it. Thank you.